All right, Stat 300 students. Working with the student this morning, I realized that there was a need to create a new video to help you out in 10.1. That some of the problems I could explain in a way that would be beneficial that's not coming across in the video, and I apologize for that. The videos that I have posted now were ones that were supplements for the class that went through this same process last semester, and so I appreciate the feedback and will seek to augment and do better in terms of providing instruction. And so you'll have a problem similar to this when you're in the 10.1 homework. And if you look in the upper right hand corner, this is problem number 3. The first two were pretty self-explanatory. But question number 3, there's this whole idea of a null and alternative hypothesis that I didn't explain. And so the reason why I didn't explain it is because I didn't think it came up. And you can see that it's only in this one problem. And so there's two goals that I have in creating this video. Number one, to show you how to deal with this null and alternative hypothesis. And number two, to show you on another problem how to use Statcrunch to help you come up with the scatter plots and also the R value and not be super calculator heavy. So as we're here in the 10.1, the claim here is there's sufficient evidence to support the claim that there is a linear correlation between the bears and their chest size. And so regardless of what the claim is, the null hypothesis is always equal to, and the alternative hypothesis is always not equal to. And what the null hypothesis is, we want to put zeros in here. Now let me explain why. What you're hoping to show is that there is linear correlation. So you have linear correlation if you are close to 1. But certainly you have linear correlation. We have no linear correlation if you're 0. So what we're hoping to do in this thing is to reject the null hypothesis, this H sub 0. They refer to that as the null hypothesis. And so this H sub 0 that's right here at this first line that my cursor is going over, we're hoping to reject that. We would love to say that we are sure that it's not 0. Okay, because if we reject the null hypothesis, we get this alternative one. The reason this is here is in chapter 8 is pretty extensive about going over hypothesis testing. And so if this was done in chapter succession, it would have been more easily understood by you what to put in there, although we would still have to talk about why it's 0. It's always 0. So when you have this in the homework, just put the 0 in there. The reason why I didn't do that is what you would find if we folded in this 10.1 section is that it'd be a little bit disjoint from the things that are being talked about there. So let me check that answer, because what I wanted you to know is once you get beyond this point, everything's the same. This is like 2.4, and that's why I put on the 10.1 is it was asked for, and it's a 2.4 reinforcement. Now what's the R value? You don't have to calculate anything. It's up here in the corner up here. Right, where I'm getting all highlighted here. The R value is this correlation coefficient. It is the 0.9750. What do they want? They want 3 decimal places, so I'll put 0.975. Didn't have to do anything, just know where to find it. What are the critical values? Well, there's 2. It's plus or minus, and they're already here plus or minus 0.268. And they're always making sure I looked. The hesitation there was me looking to make sure that it didn't round up or from that point, right? We have to round perfectly. Now, is there sufficient evidence to support the claim that there's linear correlation? Well, this is just what you were doing in 2.4. 2.68 is the benchmark, right? That's the critical value. Therefore, if I'm higher than that benchmark, closer to 1, then I have correlation. Well, 975 is closer to 1. So yes, because the absolute value of the test statistic exceeds the critical value. And so it's going to be one of these, yes, because the test statistic falls between. And it's going to be this one, because the test statistic. Now, what's the test statistic? The test statistic is the R value. So it's the 0.975. So that may have taken some explanation. The test statistic is that R value. When measuring an S size bear, is it easier to measure the chest size? Of course it is, than to get than to get that bear on some kind of scale. It'd be way easier to just get a tape around his chest. So yes, it's easier. So it's going to be one of these top three. And then remember what we decided. The chest size could be used to predict weight because there's linear correlation between the two. So it's C. Right? We're not saying one causes the other, but we're saying, hey, if there's correlation between them, I can use one to predict the other. Awesome. So this is the next question that I wanted to go over. I was looking at this same question with another student. Now the numbers are different, but we were talking about the scatter plots and how to do this. And so one thing I told them is, as we look at this, let's just take a look at a number. What it's saying, like for C, it's saying that the 14 value is really small. But if I come up here, the 14 value is 8.11. So it can't be C. How about this one? The 14 value is about 8, but it also appears that 8's the max. Do I see anything bigger than 8? I do. I see a 9. That 9's not on there, so it can't be D. How about B? That 14 value being about 8, but again, we have values that are 9, so it can't be B, so it's got to be A. Right? Just a process of elimination without doing the scatter plot, and it would tell me fantastic. Now, here's the reason why I wanted to include this in the video as well. If we're going to do the correlation coefficient, what I showed in the video was the hand way to do it, which is what I would have done in a regular class, and just giving you a truncated set of data just so you can play around with it. It would be not a great use of your time to go through that. So one thing I wanted to make you aware of is that there's always been an option here to use what they call Statcrunch. So I'm going to bring it up here and should still be in the screen area. Now, I want to make it small enough where I can see these top numbers. I don't know if I can bring this up any. Doesn't look like I can. So what you're going to do, and it's labeled across the top variable 1, variable 2. Your variable 1 is going to be the x. So you may be used to doing x in column 1 and y in column 2. You can't do that in Statcrunch. But I'm going to go put my x's in here. My x's are 10, then 8, then, whoops, I didn't get an 8. 10, then 8, then 13. Embarrassing. 10, then 8. Then 13, then 9. So if you look across the top, I'm just getting these data points in there. Now, you may think, well, this is a lot of work. It's way less work than going through the formula, which you'd have to transpose these numbers as well. So I should have 11 pieces of data. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we just double check 10, 8, 13, 9, 11, 14, 6, 4, 12, 7, 5. Perfect. So we're just making sure we've entered things correctly. Then I'm going across the y column. 9.15 was attached to the 10. The 8 had an 8.14. The 13 had an 8.74. The 9 had an 8.78. The 11 had a 9.27. The 14 had an 8.11. The 6 had a 6.13. The 4 had a 3.09. The 12 had a 9.13. The 7 had a 7.26. And the 5 had a 4.73. And you can enter them in as pairs. If that drove you nuts saying, Jensen, I had just done it as pairs. Well, we're just different, right? It's okay. However you think is most efficient for you to not transpose numbers and things like that. You can do a little quick check along the way. I usually go in reverse. I'm not seeing anything that needs to be adjusted. And so what do we do now? Well, let me show you. Let me bring this higher. I wanted you to see that data. First of all, what you could do is go to graph, and you can now put a scatter plot. Now, the x variable is going to be variable 1. That's where we put the x's. The y variable is variable 2, so they have to be in these columns. And somebody knows Statcrunch a little bit better than me and says, well, they don't have to be. Let me bring this up. The compute button's way down here. Now look what happens when I do compute. I get that same picture that you can still see over here in A. the one that we chose. Okay. Now, if I close this, it still allows me to work with my data. Now, what we've done is we're doing regression, right? So we're doing correlation, which is under regression. So if you go to this regression and go simple linear, you can select your x variable as variable 1, your y variable is variable 2. Now notice the hypothesis test down here. This is just already pre-filled in. Notice that it's 0, equals and not equals, just because that's the way it always is. Now when you hit compute, take a look at the R correlation coefficient. That's what you were after. They wanted to know the R value. We now see it as 0.8162. So they want it out to 3 decimal places. So let's remember 0.8162. We'll go ahead and shut this down. I don't think we need it anymore. 0.816. And you didn't have to go through that big formula in order to get the right R value. Now, determine whether there's significant evidence to support the claim that there's linear correlation. Well, don't overlook this. We had 11 pairs of data. Our critical value is 0.602. We're definitely above that. And we're definitely above even this other one, 0.735. So there is significant correlation. So it's one of these last two. There is sufficient evidence to support the claim that there is linear correlation between the two. Right? That's what that R value measures. It measures linear correlation. So it feels like there's a line that goes through that. But this last question is, well, take a look at the scatter plot. What would we have thought if we never saw the scatter plot? Well, we would have missed that it looks like it's quadratic in nature, not necessarily linear. It's saying that there's a line of best fit that goes probably right through here. However, it may be better to have seen the scatter plot, because the scatter plot reveals a distinct pattern that is a straight line pattern. Nope, not a straight line pattern. It's not a straight line pattern, right? So the scatter plot helps us at those times that we may have mischosen in that there might be a better way to support that data that's eventually going to come out of there. And then we're moving on to another one. And again, you can use that same Statcrunch, right? You can bring up Statcrunch again. Let's see if I bring it up. And I've totally closed it. So let's see what happens when I bring it up again. Will it have that last data in there? It doesn't. So if you wanted to keep that data, you would just minimize it. But it's kind of nice that it's all cleared out. And we would just go the 10, and maybe this time I'll go over to the next column and put 7.47. And then just continue row by row to help you out there. Alright, so I'll post this video. Well, you'll see it posted, but I wanted to make this video to help you in your homework. If you look, well, I was going to say something, but I think that's already clear in some other things, so I apologize for that last statement. I hope this helps your 10.1 experience go a little bit better.